Thanks, everybody. My name is Kent C. Dodds. I'm so excited to be here in Poland. This is my first time in Poland. I have never been here before. And I've been spending the last couple of days, and I love it. Thank you. Yeah, thank you for this wonderful city. So I am so excited to talk with you about what I think is a really important trend that we're seeing in the web developer industry. It's the next transformation. And I'll explain a little bit what that is here in a second. But earlier, G had you do some breathing exercises to help warm you up. Well, I do a little bit more than that. I'm going to ask you to please stand, if you could, physically, if that's physically possible. My clicker decided to not work. There we go. All right, put your arms out in front of you like this, and squat down, and come back up. This is called exercise. These are air squats. We're going to do 12 of these together, and I want you to count out loud with me. Ready? 1, 2, you're not counting. 3, 4, I know we're in Europe. 5, there we go. 6, 7, 8, 9, we're so close. 10, 11, this is fun. Let's start over. 1, no, just kidding. 12. Okay, stretch up over as high as you can, and then higher than that, and then stretch over to one side, and over to the other. Awesome. Doesn't that feel so good? Okay, you can sit down. Yes, thank you. This is actually really important for our brains. They need blood flow to work, and so thank you for that. Let's see if my clicker works. Yeah, there we go. So this talk is a bit of a journey through web dev and a bit of a game. We're going to play a game together. It's going to be fun. It is not comprehensive. The history of developing for the web is vast, so we're going to be a little hand-wavy over some things. How many of you have been in the web dev industry for over 10 years? Okay, a handful of you. So this will be a walk down memory lane for some of you and maybe a little education for others. But yes, there will be things that you have done in the past that we will not be covering here. But let's get started. So the web has been around standardized for over 25 years. What I find interesting is actually HTTP came after HTML and JavaScript. Yeah, I was surprised by that. And then CSS came a little bit after that. But what's even more interesting is that our mechanism for AJAX came, well, it was standardized in 2016. That was like 8 years ago, people. We were using it back in 2006. So I don't know what that says about our industry, but I have some ideas. So we've been doing this for a while. But ever since the very beginning, we've had links and forms, and that's all you need to build an application. Now, of course, we had mechanisms for building applications if browsers would install a plugin, or if users would install a plugin in their browser, but that's different. I'm just talking about what the web platform itself allowed. And from the very beginning, we've always been able to navigate between pages and allow the user to make changes to our database. So this bidirectional communication. So there are 3 architectures that have been the main architectures for how we've been building web applications since the beginning. And we're gearing up for a new transition to the next architecture. So at first we did MPAs, then progressively enhanced MPAs, so PEMPAs. I made that up, but we're going to run with that. And then single-page apps, and now we have the next transformation. Single-page apps is where we're at right now, and we're slowly moving into this next transformation. So the game we're going to play is called Follow the Code. We have different code for different use cases for an application that we're going to be focusing on. Of course, you have other use cases, different categories of code, but these are the ones we're going to be following through all these architectures. Persistence, so like your database, communication, that stuff. Routing, taking a URL and calling the right code. Data fetching, interacting with that persistence layer to get data out. Data mutation, interacting with the persistence layer to update data or delete it or whatever. Rendering logic, so how we show stuff to the user. And then UI feedback, how we show that to the user that stuff is happening, that we're giving them feedback on the fact that we're working with a network layer and things sometimes take time. So let's start with multi-page apps. This is the architecture. Whoops. Oh, that's exactly what I was worried about with the internet connection problem. But I downloaded it as well, and so it should be available right here. Yep, here it is. Beautiful. So multi-page apps. with multi-page apps, all you could do was write code on the server. There was, of course, JavaScript was there from the beginning, but you couldn't do anything really useful from an application standpoint because we didn't have Ajax yet. And so we just did new language I just invented. There we go. So we had everything on the server. Persistence routing, data fetching, mutation rendering, all of that happened on the server. And then the one thing we couldn't do was UI feedback because that was all in the client, and we weren't writing JavaScript yet. Maybe it's possible that some of you back then were having spinners, in place or something, but it was all full page refresh stuff. So here are a couple aspects of this architecture. When the user would go to your application, they would send a request to your server. The router would be responsible for calling the right data fetching stuff, which would interact with the persistence, and then the rendering logic would be called and send HTML to the browser, which would render the page. And then for mutations, the rendering logic would include a form, and then the user would submit that form, and that would make a request to your server, which would be routed to the right mutation logic, interact with persistence, and then probably send a redirect response. If you didn't do that, then the back button would actually resubmit the previous post request, which is why you get that little thing that says, don't hit the back button. And if you do, it's like, hey, warning, you're going to resubmit this post request. So you always want to do a redirect response on a successful post, by the way. But so we would send a redirect response that would go to our router, and this bottom half of this is exactly the same as the document request earlier. Okay, so that is the entire way that architecture works with multi-page apps, and still does. A lot of people are still using the MPA architecture, even starting new projects with it. So let's talk about a couple of the pros. The biggest one is the mental model is like so simple. It's like everything happens in the body of a request, and when that request is done, you don't have to think about it anymore. Now, there are exceptions to this. Of course, we have cookies and sessions that you have to think about sometimes. It can be a little complex. And doing anything like sufficiently complex is going to be a challenge. But the mental model itself, really simple. It was also, at the time, really the only way to do it. So that's why everybody was doing it this way. For the cons, though, full page refreshes were not okay. Can you imagine if you're on Twitter and you're like, I like this tweet, favorite, and it does a full page refresh? Excuse me, but no, that is, I would like fewer tweets if that's how it worked. So yeah, full page refresh doesn't really work in the types of apps that we're expecting, at least today. And it was not awesome. The other thing was page transitions, like doing animated page transitions, kind of making the web feel like an app. That was not possible. Web standards today are trying to add standards for doing page transitions between these full page refreshes, but still, that is not a thing, and it certainly wasn't on the mind of developer or the standards committees at the time. And then lack of UI feedback control. So when I click on, adding a comment on GitHub or something, it'd be nice if I could have some sort of feedback that says, hey, I'm adding your comment now. Or maybe just optimistically show it and hope that everything turns out. So we didn't have that control. So for that reason, we moved over to progressive enhancement. And progressive enhancement is about having a foundation of a functional app and then adding enhanced features because the browser has enhanced capabilities. So when Ajax came around, some browsers started adding support for the XML HTTP request object. And so as browsers started adding that, we could start doing more and more on the client until eventually we had actual, even JavaScript libraries like jQuery that would add that functionality for us to make it a little easier. So now what we have is actually all of the same stuff we had for the MPA on the server, but we also have a couple of new things like API endpoints for our UI to handle. So we have routing for that and data fetching and mutation logic for all of that. But we also get UI feedback control. And then we have a bunch of other stuff on the right as well to make it so that we don't have full page refreshes and things. So let's look at what impact this makes. So we have user enters URL. In fact, actually, this entire thing is exactly the same as an MPA. When you first come to the app, just like an MPA, except we also load JavaScript now. That's the only difference. And the reason we load JavaScript is so now we can have an app. And because now we have an app, we get another thing that is our client-side navigation. So as the user clicks on links, we're going to prevent default. We're going to say, no, don't do your full page refresh thing. Never mind. I have a router, and I'm going to determine what link they clicked on and then send them to the right code for that. So I have a router. I have data fetching code. I'm going to make a request with Ajax. I'll get that data back, and then I'll render whatever I need to based on the update. And most of the time, back in the day, we would just update the DOM directly with jQuery. We called this jQuery spaghetti. This is around the time I entered the web developer industry, and this this was not fun for even like a small project. This was really difficult. But I had a much better user experience because I'm not getting full page refreshes all the time. And then we also had inline mutation. So now you can have your Twitter favorite, or you can add a reaction on a GitHub comment, which of course wasn't a thing back in these days. But interestingly, GitHub could probably be considered a PEMPA, a progressively enhanced multi-page app. But yeah, so adding a reaction on a GitHub comment, that's an inline mutation. So something that doesn't trigger a navigation, and it's not a full page refresh. This actually looks pretty similar to our client-side navigation, except there's no navigation going on here. So we get our mutation, that makes an API call, and that comes back and we re-render. And of course, all the while we get UI feedback, so we can show a spinner or do optimistic UI or whatever. And now we also have redirect mutation requests. This is similar to like a regular mutation from an MPA. So user submits a form, we prevent default to avoid the full page refresh, and then we do our data mutation code that calls into our router on the back end, so it routes it to the right data mutation code on the back end, interacts with persistence, and then sends the response. And then we typically, because we're going somewhere else after doing this mutation, like say that you're creating a new GitHub repo, once you've created that, it's going to send you to your repo. So now we're routing over to the repo page. The repo info is retrieved from the back end, and then we render that repo info. So that is redirect mutation request with a PEMPA. Here are the pros and cons of PEMPAs. The pros are we no longer have refreshes, so that's great. Way better user experience. We can animate stuff. We can make it just focus management is a lot easier when you don't have a full page refresh. We also have UI feedback control, so we can do whatever our designers have in mind. It's not just a favicon spinner now. Now we can put like spinners in individual places. And because we have inline mutation requests, we can do like the user can submit a bunch of things and have spinners in each one of those. It's great. It can all be branded however the way we want. However, we're preventing default. Browser is really good at what it does. If the user submits a couple of forms in a row, if they're clicking on this link and then they're like, oh, never mind, I want to go to that link, whatever, they handle all of that for us. And they handle race conditions and everything as well. And so, yeah, it ends up being a lot better than what we typically write ourselves. In addition, we have a lot of custom code. And I know that like causation does not, oh shoot, what is that phrase? Correlation does not imply causation. But most of the time, I notice when we have a lot of code, we probably have more bugs as well. And that, at least in my apps, that has been my experience. This one was a big one. Code duplication is huge. So here's the problem with code duplication. Let's say that you're building GitHub, you're on an issue, and you add a comment and you hit submit. So what do you need for what's going to happen next? You need to have the template for what that new comment is going to look like when it's finished, right? So you need to have some sort of template, and it's got to be in HTML or something that's interactive via JavaScript. But then on the back end, if I hit refresh, I also need the template on the back end. And GitHub is written in Ruby. So I have completely different duplication of code in completely different languages. So this is a problem. This is a big problem. Because the challenge with a PEMPA is you have to be able to say, if it's truly progressively enhanced, my app should operate almost exactly the same whether I have JavaScript on the client or not. If you don't do that, then it's not progressive enhancement. It's like something else that is not as good. So we had a lot of code duplication. This was extremely painful. And those of you who lived through this time period probably know what I'm talking about. The next thing is code organization. We were doing jQuery or MooTools or whatever DOM mutation nonsense, and it was just like, wow, this was not fun. So code organization was a lot trickier. And server and client interaction was hard too. Basically, this involved when you were trying to follow the code path, especially over the network layer, you're opening like 30 different files and potentially 2 or 3 different repos to follow the code path for what's going on when the user does some sort of interaction. So that was also a big pain. So for these reasons, we went to the SPA, the single page app. The vast majority of the industry building new apps today are building them with single page app architecture. This is exactly the same as a PEMPA, except for there's no rendering logic on the server. So we just like, you know what, this code duplication is such a nightmare. Let's delete that. Just get it off of the server. In addition, we delete a bunch of routing and data mutation and stuff code on the server, because now our server is just an API server. For myself, I loved this because I'm a front-end engineer, or I was primarily a front-end engineer, and I didn't even want to run the back-end on my machine. Get that JavaScript runtime environment off of my machine. I'm just running my JavaScript stuff, and I'm going to hit the staging environment, and things are beautiful in some ways. So single-page app architecture changes drastically with the document request. So instead, we're putting index.html on a server, a static file server somewhere, CDN. And so that comes back to our browser really fast. This is how I convinced myself that a SPA was better, because the CDN can send the response, a spinner, like really fast. And I was like, oh, perceived performance, that's better. That's a total lie. It is not better. But I convinced myself of that so I could have this architecture. So when the browser renders the HTML, now it's got to load the JavaScript. And then when the JavaScript loads, now it's running the router. And maybe there's code splitting involved, and so it's got to load more JavaScript. And then it can fetch some data, and then that data can come back, and we can render it. And then maybe we rendered an image, and so now it's got to go get the image. This is not good. This is bad. And this is our experience on the web a lot. You go to your banking website, your power company, youtube.com. If you go to that, you get like nonsense nothing for quite a while until it downloads like 2 megabytes of JavaScript and executes all that. So this is what we moved to. And what's interesting is the other things, this is exactly like a PEMPA, no change. This is exactly like that went back too far. Also, just like a PEMPA, no change. Just like a PEMPA, no change. The only change we made was to make the document request way worse. But we did get one thing out of this, and this is the whole reason we did it, was we didn't have code duplication anymore, because we just deleted all the code that was on the server that was duplicated. So that was nice, I guess. Maybe also you don't have to worry about running a server, so okay. But we still have most of the PEMPA cons. Like most of those things are still a problem. And we also have a bundle size. Our bundles just grew enormously. We have waterfall requests, as I was describing, the document, then the JavaScript, and then the data, and then the images. We have runtime performance problems. I've got a link to a document at the end that it's not just how big the bundle is for the download aspect of this, but it's also the execution of all that JavaScript is a big problem. And state management. It's the worst. We didn't have state management with MPAs. That was just not a thing. You didn't think about it. Like, yeah, maybe you had some stuff in a session, but like, good grief. As evidence for why state management is such a problem, just look at how many state management libraries there are. And that's actually a pretty good test for how complex something is how many people are trying to solve the problem. We're not satisfied with the solutions that other people have developed, so we make our own, and what a pain, enormous pain. So, this is really not good. I'm ready for something new, something much better. I'm really ready for something much better. Really excited. I hope you're excited for the next transition. This is it. This is where we're going. Progressively enhanced single-page apps. PESPAs. Sounds like Vespa from Luca. Anybody watch Luca? Is this GIF like, okay, it's not completely falling flat for it. Luca's great. Go watch Luca. But in the movie, they really want a PESPA. So that's what, or a Vespa. A PESPA, progressively enhanced single-page app, is pretty different from our other architectures. In this, you don't have code duplication because you're actually running the same code on both sides, the client and the server. Meteor.js actually kind of pioneered this idea of running the same code on both sides. Years ago, for various reasons, that didn't actually work out too well. But now we're ready for this, and this is awesome. This is really cool. Let me show you what this means. So, the document request. This looks just like a PEMPA. No difference. We're getting the thing, it's all rendering on the server, sending the HTML, all of that. And then we load JavaScript. We may or may not actually hydrate the JavaScript. We've got interesting frameworks coming up now that are avoiding the whole hydration piece, which is interesting. for client-side navigation, now when the user clicks on the link, the router is both on the front end and the back end. And so the router takes care of sending it to the router on the back end and calling the data mutation code, or the data fetching code that lives on the back end. And then that comes back and the router sends that over to the rendering side. And all the while, of course, we've got that UI feedback going on. For our inline mutation request, that goes to the router, heads over to the data mutation code on the server, and then that goes back to the router to send it back to, or to revalidate the data that's on the page and send that back to our rendering logic. This actually looks a lot like an MPA when we did mutations. And we didn't have inline mutations with MPAs, but we have them with PESPAs, and we have the same mental model that we had with MPAs. So this is nice. And this actually right here means you don't need a state management library when you're using a PESPA architecture, which is pretty cool. We'll talk about that a little bit more in a sec. And then for redirect mutation requests, this actually looks exactly the same. No change. And this means that we get the simple mental model of MPAs. So if you're like pining over how simple it was back in the MPA days, and you're like, why can't it just be as simple as that was? That's what PESPA has to offer. Is we can have that same simple mental model that we had with MPAs, which I think is brilliant. I'm really excited about this because I like simple. It also means we don't get full page refreshes because we've actually got JavaScript and client-side navigations, all of that. We get our UI feedback control, so that's nice. We can do optimistic UI or pending UI, whatever you want to do, and it's quite nice. The browser emulation here, so this is part of what makes it so that we get the MPA mental model, is we're just emulating what the browser does. So earlier, here, let's go back actually. Let me get a little closer to here. So by doing the mutation and then revalidating the data that's on the page, we're emulating what the browser would have done. That's why we have the same sort of architecture as an MPA, is because this validation logic happens automatically. So you don't have to worry about state management because we emulate the browser. So yeah, you get that browser emulation, and it's really awesome. And that's just like re-implementing what the browser would have done in effective way so that it actually is doing what the browser would have done and not doing it worse. No code duplication because it is the same code. The UI that's running on the server is the same as the UI that's running in the browser. And we'll look at code here in just a second to see what that looks like. We're reducing the amount of client-side JS because we're shoving everything back into the server. Just all that data stuff, management of data, data fetching, data mutation logic, just shove it all back to the server. That actually has an enormous impact because probably 30 to 50% of your code that you're writing for your UI is, well, around state management. So skipping ahead a little bit. So there's a lot of code that you just delete because of that, but also because we're just shoving so much over to the server. We don't have waterfalls because it's the same sort of thing as with a Pempa. All of that UI, like the images, everything, shows up in the HTML right from the start, and so the browser can start showing those images while you're downloading any JavaScript you need on the back end or behind the scenes. And then again, as I said, no state management, which is like fantastic. Of course, you have like components and component state management. You know, you need to be able to say whether the modal should be open or not. But that's not the hard part. That part's easy. It's the entire application managing that state that's really, really a challenge. So you don't have to worry about that with PESPAs. So cons are interesting because when you enter a new transition, you're trying something new, it's kind of like when you're dating somebody and you're like, wow, they're amazing, and there's nothing wrong with them because they're just so awesome, and then like eventually you find out all the things that actually are wrong with them because all of us have problems and none of us are free of that. That's the same sort of thing. So we actually don't know everything that's wrong with the PESPA. But we have a couple of ideas, and I have some like pushback on some of these ideas. So one thing that people will say is, well, now you got to have a server. With a SPA, I didn't have to have a server. I just like shoved this stuff on a CDN, and it was magical. Well, I've got news for you. Anything that like, I would say probably 95, maybe 99% of the things that we do for our day jobs is going to have a server. There's going to be a server somewhere because you're going to have data that you need to access. So even when your SPA shows up on the user's browser, it's probably making requests, and there's a server that's responding to those requests. So you're not going to be able to avoid a server for anything that we're getting paid to do. So yes, it requires servers, but you already got them. So I'm not sure how this is too much of an argument. Also, another thing people say, well, it costs a lot. Well, we've got Cloudflare over here allowing you to serve 1 million requests for 15 cents. So, I mean, I don't know. This seems like pretty okay to have a little bit of server costs. And in addition to that, in addition to that, we also, you got to think about the impact on your users. And ultimately, if your competition can outperform you, then it doesn't matter how much you're spending because you're out of business. So I think it's an okay investment to make. But yes, there is potentially more server cost, but probably not nearly as much as you might think. And then the other thing was, with a SPA, we can just assume that everything's running in the client, but with a PESPA, we have to be able to write code that runs on both. It needs to be able to run on the server, it needs to be able to run on the client. Now, you can have some stuff that you're like, oh, this only runs on the client, and there are absolutely ways that are established to be able to do that. And there are situations where you need to, because you can't interact with a canvas, you can't interact with a geolocation API, like Bluetooth API, stuff like that. So there's definitely stuff that's client-side only. But for a lot of stuff, you need to write it in a way that it will at least execute on the server. And that can be a challenge, for sure. But I would say that if it only executes on the client, it's a worse user experience. Anyway, I call that a bug. So fix your bugs, I guess. We will definitely discover more problems. We're in the honeymoon phase of this new transition. There will be problems, for sure. But I am very excited about these pros. Very excited. I'm glad that it's not just about the developer experience this time. So here's an implementation of PESPA. In fact, Remix is the only implementation of a PESPA we have so far, but others are following suit. So Solid Start, Solid.js framework, and SvelteKit are both adding features of what I've described as a PESPA very soon. So Remix is the bridge that makes it feel like your code transfers from the server to the front end very seamlessly. And I'll show you an example of that here right now. So in Remix, if we had this projects page where we load different projects, we'll have this app routes projects file. So let's explore this code a little bit. This loader runs only on the server. That code's only there. So you can use private keys, you can, there's no CORS issues, whatever. You can talk to other services, whatever you need to do, talk directly to the database. And our persistence code is that get project. So whatever the implementation for that is, that's our persistence code. So that will respond with JSON, and then in our UI, I was about to say on the client, but this isn't just on the client. This is actually both client and server for our UI. So for our UI, we get the data that our loader returned, and then we can render that however we want. So here's our rendering logic. We also render this form. The form resembles what the regular MPA type form is, and it actually will work the same way that a regular form would if it takes too long to load our JavaScript for some reason. So the user loads the page, they're on a slow internet connection here at a conference or something, they get the HTML, they submit the form, and it will work before the JavaScript is finished loading. So that's neat. But what's really cool about that is it's the evidence that we don't need a state management library when we're using a PESPA architecture, because everything is built with progressive enhancement in mind. So when we submit that form, we are going to be able to hook into the transitions that are happening so we can show a pending state. So we get use transition, we know that we're in a submitting state, and so we can determine what the button says or show a loading spinner or whatever. So this is our UI feedback code, all right here in the same file as well. And then when that is submitted, Remix is going to submit that request to our action, and then we can do whatever we need to. Again, this is server-side only code, so whatever mutation you need to do, including validation. So if you have some sort of error, then you can send that back to the front or to the UI, to the front end, and then that can be used to display whatever errors you want to or whatever. Or you end up redirecting because you successfully created the repo or whatever it was. So that is an example of the PESPA architecture with Remix. Amazing. This is all one file. That's awesome. And you need to move code around, share code. It's all just JavaScript. You just move stuff around. But we've reduced the bundle size. We have drastically simplified the mental model. We avoid state management, all of the things that I said. amazing. So this is why I'm super stoked about Remix, and why if you haven't used it or tried it yet, I strongly advise that you do, because it is ushering in a new transition for the web, and I think that's important. And stuff like this happens. You're just building your app, and then, oh yeah, maybe I should like try a Lighthouse score test on this, I don't know, just for fun. And you get 100 performance score, and you're like, oh, I guess my work is done. I don't need to worry about optimizing that. Whoops, I guess it just works. Like, those are pretty dang good scores. That's awesome. And look what he says about it. It's authenticated on our most expensive page, no caching of static assets. And this is just because of the architecture of a PESPA. Pay attention, folks. This is awesome. So I've got a couple resources for you, so feel free to check these out. The last thing I've got on this is the implementation GitHub repo. So I implemented the same app in all of these architectures so you can kind of compare. So check that out. My slides are on the last, or a link to my slides are on the last slide here. I just have one last thing to say to you, and that is, you belong here. Thank you.